When I found out our next speaker was from NASA, I was really excited to have a talk about space. Then he said he's going to talk about people, not space. But that's okay, I'm still interested in people too. And way back in 1977, our speaker was 15 years old. And his friend came over and he had an extra ticket to go see two bands. But our speaker's dad really wasn't in the mood, so he wasn't going to push it. So he asked his friend who the bands were. And the friend said AC/DC and Journey. And our speaker didn't know who those bands were, so he said, okay, no big deal. Now he knows better. Everyone, please welcome David.
So what I want to do today is talk a little bit about it, and I appreciate, Jared, the introduction, and it was definitely very interesting. That time in my life when I had to make decisions, and unfortunately at that time I made the wrong decision, but hopefully over the years I made better decisions. And when we look at decisions and we're looking at trying to figure out our ability to look at our skill sets across NASA, I was asked to take a look at how we're developing our skill sets across our information, across our different things. So let me give a little bit of an idea of what we're trying to do in developing a knowledge graph across NASA. Let me start here. So first thing, as we take a look at NASA, here should kind of give you an idea of where we are and what we do. We've got various different centers, 10 different centers, another 6 or 7 facilities, and we also have a research lab that kind of floats to a couple hundred miles above the Earth, where we have to identify our workers, our abilities, and our different skills, and we've got a lot of different programs and projects going on. Of course, now we've got a big mission underway of trying to get back to the moon and onto Mars, and we have to identify the skill sets across our organizations, and each of these centers do different things. We have research centers that focus on medical issues. We've got other research centers that look at propulsion or heliophysics or planetary science and climate control. We also have our engineering areas like Johnson Space Center and Kennedy Space Center that work on actually getting our human exploration. So there's a lot of skill sets are strewn across all across the United States and across different programs, and each center does different things. But we really need to identify where they're all located and how we can better utilize these skill sets. So as we start thinking about this, and I was brought into human capital about a year ago to take a look at this, I first had to understand what our architecture looked like. And as we take a look at our analytical architecture, when I first started this organization, we had the far left and the far right, and that was about it. We had some ways of acquiring data, and we had ways of showing data, but nothing in the middle. So over the last 6 to 8 months, I've been trying to slowly integrate various tool sets into our pipeline to allow us to connect to our skill sets, to allow us to connect to our data, actually, to identify our skill sets and do various things across human capital with people analytics. But one of the major problems I had, or not problems, but an issue or concern, was that we had everybody doing different things. We had various skill sets across even our employees doing analysis. Some people use Python, some people use Ruby, other people use R. So I wanted to try to find platforms and connections of how we can do all of this together. So the example I'm going to show here today is really how we can combine not only various technologies to do this analysis, but how to do this in a way seamlessly to be able to share data across internally that can help us across the agency. So we'll see how I connect from different data sources like a Neo4j graph database into utilizing both Python and R through some machine learning and eventually to a visualization aspect of that. So how do we create knowledge graphs? First of all, a knowledge graph is basically an understanding of a particular domain with various relationships across this domain. We ask different questions, we define a model, we do some analysis, and the various tool sets that I'm using here today are going to be Neo4j, R and RStudio, and Python, along with various algorithms inside both of these packages. You can find my code for this at that GitHub repository. And be able to update and actually do some of this work on your own, because we have some open source data that's available with that. Why are we doing this? Well, and when Gartner surveyed various different HR executives, the top 2 things on 2 different surveys was critical skills, building critical skills and competencies, as well as the emergence of new tasks and responsibilities for employees. So those are the type of things that we're really looking for, not only at NASA, but it turns out that most of the industry is also trying to figure out ways of improving their skills. primarily because of the way things are going on now with the COVID situation and new ways of doing business. So this has really come to the forefront, and it's really a way of looking at not only NASA skills, but across the industry skills. So what can you do with these things? There's a lot of different things we've looked at and what we can analyze with. And one of the things is where's our actual skills across the workforce? Can we actually identify what project, what program, what theme or mission actually has these type of groups of skills? And it turns out we can to a degree. Can we identify adjacent skills? If somebody knows Cypher, do they also know SQL or Python and R? How can we do some kind of adjacencies on that? And if I want to change careers, what should I learn? As we start infusing more things into our knowledge graph, we can add things such as training information, curriculum, objectives of that to identify skills and knowledge that may be attained in that. But now let's try to put this all together. We can start with a current database that's currently out there called ONET by the Department of Labor that actually has a little over 1,000 occupations already developed into a database that they've looked at over the last 60 or 70 years. They've created this, and each of these databases has some elements. Those elements are made up of skills, knowledge, tasks, and abilities, and the data model looks something like this. So on the far left-hand side, you have an ONET database that we pulled down from the Department of Labor, and we can break this down into a graph model. And in the graph model, the circles here represent nodes or entities, and the lines represent relationships across those nodes or entities. So the elements that make up an occupation are broken down into things such as tool use, work activities, abilities, knowledge, tasks, skills, etc. Those can be found in occupations. Well, that's just part of the database. The knowledge graph can be expanded to include NASA information such as what OPM series, and that in itself is just our NASA government code or our government code as to what kind of occupation it is. But that could also be related to an employee. And how do we get information from the employee? Well, we've taken information from the employee's position description, run some similarity analysis between the position description and the elements within the ONET database to try to identify which of those elements may also be found in an employee and build that back into the graph, as well as provide an additional information about where they charge to find out how we might be able to see what skills each employee has and how they're applying it to different programs and projects. That kind of gives you a little semblance of a knowledge graph in itself and how we created this around a graph model to look at our skills. But how do we build this? How do we actually do something like this? So I developed this kind of a knowledge graph model of what we're trying to do, just kind of real quickly showcase how this all works together. On the left-hand side, you have occupations, again from the ONET, that we extract the different KSATTs, the knowledge, skills, abilities, and tasks. Those we use to create a vocabulary that will train a DrVeC model that will be stored and allow us to utilize that and infer against the employee's description. On the right-hand side, we have these employees. And from the employees, we have different information, the job descriptions, performance evaluations, resumes, and CVs, and training. And from that, we can use that information to infer against the DrVeC model and maybe pull out various skills, knowledge, and elements that may be found in that database. Add all that together in a graph database, put it all together, run some graph algorithms against that, and start to identify different things as skill gaps, career paths, succession planning, and maybe a strategic alignment model. Those are the types of things you can do with the graph model, but first we got to get that all in together. And I'm going to show you really quick how we did that and how you might be able to look at that and pull out some information from this graph model. So we first start off. Here's where I start combining the world of Python and R and everything together. With the help of some interns and some different folks in my team, we were able to create a Python script that, when run, connects back to your Neo4j graph database and actually pulls the ONET database directly from the website, runs some algorithms, creates the constraints, inserts the graph database, makes the relationships, and within a matter of about 20 minutes, roughly, depending again on your resources and what you have, you come up with something like this in the graph database. Now, of course, yeah, this looks a little bit, it looks a little weird and wild and but not like the graph model I showed you earlier. But trust me, it has all the information in the graph model. Everything here in the colored are the elements that came from the occupation on the two nodes on the far right-hand side of the occupations. And the elements inside of that, the interests, the abilities, the tasks are all related back to the occupation. But you also start seeing other patterns and other connections here. On the left-hand side over here, towards the bottom left, you see that's the actual charge codes and where somebody's paying to, and we can start seeing those relationships, which will eventually get associated back to an employee and back to an occupation. And I'll show how that works and give you an example of what that looks like in a little bit. So now that we have the graph database, we've got to create our DrVeC functions in order for us to be able to infer against the employee's information. So here are some of the functions that we've created to clean the test, create the model, and I'll expand on a few here to show exactly what we're doing to get this information. But we're combining, I think what I want to really want to get across here is we're combining various technologies. Here we're combining some Python scripts, connecting back to a Neo4j graph database, and then eventually use some R scripts to do some more major cleaning. Because as an primary R user, I'm more familiar with doing a lot of the analysis in R than Python. So we're having to mix these together, showing how as a team we can work together with various technologies. So in order to create the model, the first thing we need to do is actually build a vocabulary for that model, and we use a Cypher Query that we store into a Python script here to connect to the graph database and pull that information out of the actual graph database. So what we're doing here in simplest terms is with this query, I'm pulling out all of the information about all the elements associated to occupations. And I'm using that as the vocabulary to build my model, my DrVeC model using the Gensim package within Python. And I'm looking at a vector size down at the bottom. You can see a vector size of about 200 using the skipgram model with the minimum count of at least 2 for the words, using 50 epochs and a window of 4 across the words themselves to look at the context of the words and how they may be related to each other. So once I've built the model, I can then go back to R, where I need to do some pre-cleaning and some changing of my employee information. It's very, one of the things that always gets me all the time is how we've been around for 50 plus years here at NASA, and we've got data all over the place, and we've used so many different ways of structuring our data. We're still struggling how to get our data governance in play to make sure that we share information alike. Even within our employee information, some information in here, in this particular case, what you see with the EPDS series up here at the top is our codes for our occupations come in 3 different formats, and so I needed to make sure I can relate them back together. So I'm combining the codes and adding some information in order so that it all looks the same across all the different platforms. Then I'm creating here the DrVeC or the document sections for what I'm going to infer back into the DrVeC model. So in here, I'm tokenizing the documents, the position descriptions of the employees into sentences, and I'm going to use the sentences as the individual documents so that I can infer those back to a particular skill or knowledge or task or something within the ONET database. Once I've done that, I've saved that back into a CSV, so that I can then utilize that back into the Python scripts to pull that, infer that information back into the DrVeC model. So in this particular case, the top function here is basically tagging the position description information, tokenizing and tagging that so I can utilize that in the DrVeC model. So each of those words are tagged with an appropriate sentence ID. That allows me to use that information to figure out how to find a similar elements, the knowledge, skills, or abilities with that may relate back to the position description. The bottom script there, and I just noticed that it's named top 10 similar, but if you really look, I'm only pulling up the top 3. We've played around with how many different similarities scores we're pulling out. So this function basically takes that infers that those tag documents from the position description against the DrVeC model and finds the top 3 most similar elements within that information. And then it returns back to me basically a data frame that looks something like this. It's got my position description, which is the ID for that sentence. So and the numbers basically represent the UU pick, which is the individual ID of an employee, the position description number, the 303 in this top line is actually the OPM or the job code for that individual, and then the 1 represents the sentence that it came from, so that I connect those relationships back to that individual sentence. And here are the top 3 similar elements found. As you can see within this one sentence, it's saying that with the 46% similarity, it's close to a basic skill entry requirement of active listening. It's also 45% close to a competency of negotiation, and 44% close to a work style of stress tolerance. I guess from, if you think about it, if you're doing a lot of negotiation and really listening, you got to have some good tolerance for stress when you're trying to do a lot of that work. But you'll see that this is how it's trying to pull up those top 3 things. But it's not very easy for me to utilize this information to put it back into the Neo4j graph database. So I go back to R, where I read that information in. I do some cleaning up, some rearranging, some separating of the position input numbers, so that I can spread that across and actually identify these things. And once I do all of this, I then come back to a formatted output that has separated it all and allows me to see the various labels for the node entities of knowledge, the titles, the similarities, and how they may be represented back to a particular sentence within an employee's position description. All of this information will get placed back into the Neo4j graph database. I'll utilize scripts here to make the relationships between the employee and the individual node or knowledge or element node, whether it be knowledge, skills, abilities, and make that relationship back utilizing the weight of similarity, so that we can try to play around a little bit with that to see how close they may be related. Once all of that information back is put into the graph database, I can start doing visualizations like this out of the graph database. So in this particular case, I'm looking at an individual here, and actually myself, David. I pulled this out of the node, and I have associated all these various skills and elements that were found within my position description that are also related to my current occupation, computer and information research scientist. So all of that we're showing how related they are and what the most important elements or skills are found in that occupation, as well as in my current position description. But now I can also associate back to what where I charge to, not only what program or project, but what mission and what theme, and all the way back down to an official division that I may be charging to. So now as a manager, I can ask the question, what skills do I have in my particular program or project or theme, by aggregating all of this information back up the chain and identifying where my skills are associated. So it allows me to ask a lot of questions like, do I have the right skills in my program? What skills are lacking? What skills are missing? Allowing me to start really trying to identify what I need to do to change and maybe improve upon my organization, but also help find individuals that may be useful for my program. So how do I do that? I now turn to going back directly into Neo4j with some different Cypher queries. And if you're not familiar with graph databases, a Cypher query is the equivalent of a SQL query within a regular relational database model that can pull out information. So in this particular case, after I've ingested all that information, I've taken the information from ONET, I've added some more information from my employee information utilizing this DrVeC model and put that all into a graph database. I can start asking questions such as this, as to what rank skills by occupation. One of the information pieces that comes out of ONET is that they do an assessment of all the skills of how important they are to a particular job. So in this case, I just pulled out the information for computer and information research scientists and looked at a few of the basic skills and the importance level. And here, the most important thing that was identified by ONET was that understanding written sentences was the most important skill for research, computer and information research scientists, even higher than using mathematics to solve problems. But even if you look at the top 5 skills here are more about communication and giving attention than it is about actually doing mathematics and solving problems for your basic skills. So it shows how important it is communication is across any occupation. But there's more things we can do with this type of information. What if I wanted to do a career change? What if I'm a management analyst, somebody that's doing just the research reports, and I want to see, I really want to get into maybe a business intelligence and doing some more things like that. Utilizing this query, I can pull out information about management analysts and other occupations that may be similar to management analysts based on the number of nodes that intersect across those. So the number of skills or knowledge that intersecting across management and other IT type skills. And as you can see, business intelligence analyst is about 46% similar to a management analyst. So it tells me what skills are similar, what knowledge is similar, but it also tells me what skills and knowledge I need to gain in order to attain my my goal of becoming maybe a business intelligence analyst or some other career. So it allows us to start seeing how we can move people around in different locations, or if I'm a project manager and I need a business intelligence analyst, I can go research my employees and find out who's close, may have an interest that I can upskill to make them a business intelligence analyst. So there's a lot of different things we can do as we move through this. And speaking of, as far as looking at employees, one of the things we can do here is find similar employees. So if I have a program or project and I need particular skills, I can utilize a query like this to find employees that match those skills and knowledge for my program and project, and start reaching out to them to see if they're available to join my program or project at that time. So another way we can identify skills and utilize these things across the organization. The last thing I want to show here really quick is, as you try to combine all this together, is how do we start visualizing these things? This kudos goes out to my current intern, Madison Gibson, who created this little dash app that we're going to put back into our RConnect server to be able to utilize it. But I'll show this video really quick here, which shows it connecting to the Neo4j Graph database. You start putting in information that you may be looking for. And here again, we're looking for computer and information research scientists, and it clicks similar occupations in computer and information research scientists that can be found within the organization and how similar they are based on the nodes they share, the skills, the knowledge, the interests and things that they're shared across the occupation. I could do this, we could do this for employees and various different things also, but for privacy reasons, this is the only thing I could show, but those are ways that we can share information across. So as you can see across this thing, we've done a lot of work to this, trying to develop skills across the organization. But there's still more to come. We can do things as recommendation engines for people that are looking for maybe small projects to work on. I have a certain skill, what jobs are available, or vice versa. Can I find experts in the field? Also, as we add training information, we can develop training plans. I want to get to a particular career goal. This is what I want to do. What training do I need to take based on how those training objectives inform or add to the skills that I want to learn, and it'll help us outline career path. So in this 20 minutes or so, what I really wanted to show is how we utilize various technologies to try to develop these skills, combine them together to be able to share across the organization, ways of sharing information, building upon what we currently have in order to be utilized all our information. So hopefully I stuck the landing here. And you're welcome to reach out to me or to my current intern on some of this work we've done. If you have any questions, I'd be more than happy to connect and answer questions offline. At this point, I want to thank everybody for their time, and I pass it back to Jared.
Thank you very much, David. I wonder how much of that you use on astronauts. Coming up next is our time to do blah, blah, blah.